Hey guys, good morning and welcome to this open masterclass on VPC. My name is Mahendra Pandey and I conduct these open masterclasses I've been doing from past uh, 3 or 4 weeks, I suppose. And the aim is to basically present some good content for people, those who want to consume, those who want to learn a bit about AWS. I work as a freelance cloud solutions architect come trainer, having more than 18 years of experience, have been certified in multiple technologies, and right now I'm working as AWS authorized instructor and Google GCP authorized instructor. Now let's have a look at the agenda, what we are going to cover for today. The topic that we are going to focus on today is VPC, one of the most important topics when we talk about infrastructure management in AWS. This VPC basically lays down the foundation for learning other important topics. For example, whenever we talk about EC2 virtual machines, or we talk about uh, other infrastructure related services that we may be talking about in the upcoming open master classes. So the basis for why I've decided to cover VPC today is because upcoming open master classes that we are going to have in forthcoming Saturdays, weekends, will cover topics that will need VPC having as a foundational knowledge that you need to have. So the focus today is going to be on AWS networking, what role virtual private cloud plays. We'll also see how to set up different VPC components. We are going to talk about VPC, subnets, route tables, internet gateway, right? Some of the most important components of VPC. Then I'm also going to talk about private connectivity and why private connectivity happens to be the option when you're trying to connect multiple networks together. What is the difference between private connectivity and hybrid networking? So as you can see, topic 4, this is about hybrid networking. This is where we are going to talk about virtual private network, transit gateway, and direct connect. We will complete all this by talking about topic number 5 is going to be about VPC security. This is where I'm going to cover security group and network access control list. Once we are through with this, we are going to keep the session open for around 10 minutes or 15, whatever is comfortable, and we'll take question and answers. If you have any queries, be it related to VPC or anything that you're seeking as an information from VPC perspective for your exam preparation that you may be doing. As you know, the format of this open masterclass has always been uh, without using any kind of slides. So this is where the slide part completes. I'm not going to continue with any other slides that we may have. I'm going to basically focus on Blackboard. So we draw, we talk about, and then I'm going to move on and show you the demo, the proof of concept. So let's get started with the first topic in the list. What is AWS networking and role of VPC? As you can see, this dashboard. Now, before we can move on and I start talking about VPC on AWS Management Console, let me first talk to you about networking, how VPC works, and how is it designed and why is it designed the way it is. So bringing up the Blackboard here. You can give me a minute. Yep. Apologies. Suppose my Blackboard was not connected. Okay, so getting started about VPC, but first thing that we will talk about in VPC is networking. Now, whenever we talk about computer networking or device networking, we want to make sure that we have multiple nodes or computers, servers, client, whatever you talk about. We just want to make sure that these two are connected, or as many computers as you have. We want connection, one computer to talk to the other one. Now, I'm not going to get into the discussion of devices. There are multiple devices that can be used. We use different types of cables, switches, routers, but those are all physical components that you use to make sure that all the machines are connected within the network. Now, let's keep the physical connectivity part away from this, and let's talk about the logical connection. The logical connection will need that if there are multiple computers connected together, they should be able to talk to each other by calling each other's name in a way. Now, I'm not saying that computers do have a name, which in case they absolutely do, but I'm basically talking about and trying to bring to your attention the concept of IP addressing. All the computers that you have connected in the network are definitely going to have IP addresses associated with them, and these IP addresses will help each of these systems to call each other by the IP address and to talk to each other, right? But apart from IP, you might have seen we also have something called as subnet mask and a default gateway. An IP address is a logical address of each of these systems to talk to each other. The subnet mask here basically represents what portion of IP address will be seen as network address and what portion is going to be seen as host portion or host address. Now, as we all know, IP addresses are 32 bits, and these 32 bits are divided into 8 bits, dot 8 bits, dot 8 bits. 8 fours are 32. So 8 bits dot 8 bits dot 8 bits. Minimum value, if I try to convert these 8 bits into binary, the minimum that you'll get out of this is keeping all the bits as 0. And if you try to add up all, that means taking 8 bits and keeping 2 as the base, you'll find that the address, the max that it can go to is 255. So 0 to 255 is a total of 256 in a way, to basically put it across like that. Now, this is decimal to binary conversion. Again, this is not something that I'm going to focus on. You can learn more about it by reading and trying to Google this. But keeping this, I want you to focus on that the highest that you can have by keeping all the bits high is 255. Now let's take an example of an IP address. Here, if I use IP address 192.168.1.10, that's the IP address. Now, if you are sending a packet from one computer to the other, the same way as in old times when we used to send letters, maybe if you've ever had a chance and lucky enough to have sent any kind of letter to your friend or to a relative, the first thing that you do is, if you want the letter to be delivered, is you need to define not just the building where the person may be living, but you need to define the area. Say for example, if I want to send a letter to my friend in Delhi, I need to define that in Delhi, apart from his building, which area. Let's say my friend lives in Lajpat Nagar. Now, if I'm defining the address, let's say 210, that is the flat number and the building name, and then defining the entire address, you'll define the area. As and when courier picks up the letter, or post office picks up the letter, it is going to deliver to the area first, right? Lajpat Nagar. And from Lajpat Nagar, the post office is going to search for the building and then the flat where the letter or the data that needs to be delivered. In the same way, here in IP addressing, whenever we talk about, the subnet mask plays an important part to represent which portion is going to be network address and which portion is going to be host address. So this is the subnet mask that I'm putting in 255.255.0.0. If you try and perform AND operation between these two, a logical AND operation, by converting these decimal numbers to binary, you will find that the final address that you are going to get is going to be 192.168.0.0. What that means is 192.168 is the network portion. Reach out to this network first, and then in this network I want you to search for the host having an address of 1.0 in this case here. So machine actually does that. If you see this, it's not just that I'm saying. Machine basically performs an AND operation to figure out that this is the network and the remaining portion happens to be the host. So once the packet reaches the network, then in that network it is going to search for the computer. So every time I'm using the term host, I'm basically referring to a computer in that network. Now, you can have multiple networks if you're in college, if you're working in an office, or if you're home. There are multiple networks that you'll have. So let's say this is my local area network. Here I have a Wi-Fi router at home, and through this Wi-Fi router I'm connecting multiple systems at home together. So these are multiple systems that I have at home, right? In the same way, there could be a different LAN that belongs to my friend who lives nearby. Another local area network could belong to another of my friend. Now, if you see, we are talking about 3 different local area networks. That means we are talking about networks, right? Maybe all these networks are connected together. Now, if this machine wants to send the data to a machine over here, to figure out how to send it, it needs to know the location, the area, the network first. So the network portion that I was talking about will figure out which network, and once the data packet reaches this network, it's going to search for the host where to deliver the packet. That's the whole idea here. So subnet mask becomes an important part. Now, talking about the subnet mask, 192.168.0.0, this represents the entire network. I'm not defining the host portion yet. That means I'm not defining the address of the virtual machine. This is just the network. That means a common factor amongst all the computers part of the same LAN happens to be the network address, right? Now this network address, if I have to define, I will also write down that the network portion is 255.255.0.0. This is an important piece of information that I'll have to define. Now the same subnet mask that I'm writing here could also be denoted in a format known as CIDR, CIDR. CIDR, classless interdomain routing. Now in CIDR format, if you have to define the subnet mask, I'm going to count bits rather than the decimal numbers. Now this is all of 8 bits high and 8 bits high, 0, 0. So a total of 16. I can easily define it in CIDR format as /16. And this is what we are going to use for our VPC. So rather than defining the subnet mask in the decimal format, we can define it in CIDR format, and here CIDR represented as a total of 16 bits high. If I keep all 16 bits high, 8 bits dot 8 bits, you'll find it as, it shows up in decimal number as 255.255. Now you might have heard about terms like subnetting and supernetting, and this is what we are going to do further. If you have a huge network, like here, I have a huge network, right? If you can calculate this 192.168.0.0, keeping a base of 2 raised to the power of a total of 16 bits available for host portion. So that means those are the number of computers that I can connect in a single LAN having the address of 192.168.0.0. Now the last portion 0.0 that we were looking at represents how many computers can you connect into the single network having a CIDR of 16. That means having a subnet mask of 255.255.0.0. Total number of systems that you can connect goes up to 65,536. Wow, those many systems, those many servers, virtual machines, whatever you call it, can be connected into a single network. But Mahendra, I'm not going to use as many systems. And another thing is, it's not good to keep your network that huge. Imagine if you have around 65,000 people in a single room, they're all trying to talk to each other, right? It's not going to be easy for you to hear your friend. So let's take an example that I'm sitting in the same room, a network, a local area network, where I have 65,000 people and all of them, they want to talk to each other, right? Is it going to be a good scene? No, sir. It's not going to be, because then all of them speaking to each other, it's going to create the kind of an environment where I may not be able to hear what my friend is trying to talk about, right? I'll have to stress. So what can I do to resolve the problem is create a partition in a single room. And I'm just taking this as a hypothetical example, if just to make sure that you can understand what I'm talking about here, is I'll take a room and I'm going to divide it into partitions such that I have fewer people, those who can sit in a room. If there are fewer people to sit in the room, I'm pretty sure that we all be able to talk and hear each other clearly. The network performance in this case that I'm talking about will improve if you have a smaller network, what we call it as a smaller broadcast domain. To do that, 192.168.0.0/16. To do that, we perform an operation called subnetting. I'm going to divide a huge network which can accommodate 65,000 computers into a smaller network. And remember, this is a single room that I've spoken about. I want to create a partition in the same room. I'm not going to change the room, right? It's going to be the same network, but I'm going to create a subnetwork, out of this huge network, and hence the word subnet, a subnetwork out of the network. Now to do that, what I do is I borrow bits from the host portion. A total of 16 bits are available for host portion. What if in case I use one bit from here, and remember I'm talking about bit operation, right? I'm using one bit from here and I want to include that into the network portion, right? If I do that, the address turns out to be /17. Why /17? Because 8 bits dot 8 bits dot 1 bit dot 0 bit, right? So I've borrowed a bit from the from the host portion into the network. Now with that, I will have two subnetworks, and each subnet is going to have 65,005 will have 32,768 systems that you can connect into each of these networks. See, the number still remains same. Two subnetworks for this network, and both subnetworks can accommodate 32,768. So if I do 32,768 multiplied by two subnets, it equates to the same number that we are looking at over here. Now it continues. So if you want more networks and fewer systems in those networks, then you can do is make it /18. With /18 you'll have 4 subnets, right? And each subnet is going to have 16,384 systems that can be connected into each of these subnetworks. So 16,384 multiplied by 4 is again 65,536. That subnetting, you can read more about this, and those who are wondering that if you have taken the bit, how is it going to be calculated as a subnet mask? It's fairly simple. So if I take it as 192.168.0.0/17, then the subnet mask is going to change, and that's going to appear as 255.255. If I convert this into all bits, 1 2 3 4 5 6 7 8.0, I'm carrying one bit over here. So 2 is to 0, 2 is to 1, 2, 4, 5, 6, and if I keep it as 2 is to 7, give me a minute here. If I take it as 2 is to 7, this particular bit that I've borrowed, 2 is to 7 is 128. That's exactly what the subnet mask is going to be. So 255.255.128.0. So 128.0 converts insider as /17. So in the same way, Mahendra, what if in case I make it 18? Sorry. If I make it 18, If you make it 18, I'm going to count 2:6. So this bit as well goes as network portion. 128 plus 64. Right? So that's going to come as 192.0. So subnet mask is going to be 255.255.192.0. Now this is all about just IP addresses and subnet mask. Another important thing that I spoke about is also gateway. Gateways are basically used for when a system cannot find another system that it's looking out for. Say for example, if this machine A wants to talk to machine B, if it cannot find B in the same network, it's the gateway where it can go and ask question and say that, hey, I'm looking out for a system with this IP address and I can't find the system in the same network, in the same LAN. Gateway is the component of your network that basically tells which network the system is in, right? And once the machine gets that info, it will be able to route to that system and the data connection establishes if they can talk to each other. So this was just a primer, just a refresher for everyone, those who just wanted some brief introduction to networking. Also, I wanted to clarify whenever we talk about reference networking, there are two things that comes into picture. Most of the time people, they talk about OSI. There's something called as OSI model of network, and then there is TCP IP model. Just to clarify what's the difference between the two, the only answer that you'll get is OSI model has 7 layers, and here they talk about 4 layers. So let me just bring up OSI versus IP model. These are reference models. Reference models is basically a part where whenever you are trying to understand, you understand using OSI reference model, but the actual implementation of it happens to be through TCP IP model. So as you can see here, the OSI model happens to be defined in 7 layers, but the TCP IP model happens to be 4 layers. The reason is application, presentation, and session in TCP IP model are amalgamated. They are part of the same thing, and hence you have 4 layers. So OSI happens to be a reference model for whenever you're trying to understand how application networking and application code is to be written probably. But TCP IP model is the actual implementation. The way how you implement it is through TCP IP model. Now going back, and now I'm going to start with VPC. I suppose that base info was enough for us to get started with VPC. As the name implies, virtual private cloud. Virtual because it's not physical, it does not exist physically, right? It's kind of software defined networking. You don't have any kind of router, switches, or cables to be managed. As I say, it's software defined networking. Private here represents private IP address space. Your IP address happens to be divided into two parts in a way where a particular set of IP address is used for home, office, or LAN purposes to be used for your own private internet purposes. Whereas we have public IP addresses. Those are the IP addresses which are routable on the internet. All of this is defined in RFC 1918. Hence we call it RFC 1918 address space. So if you try to read this, you'll find that these addresses are reserved as private IP addresses. Now, when I say private IP addresses, what I'm trying to say is these addresses are not routable on the internet. You can't use it on internet. It does not work. Whereas if you go and try to find out your own IP address of the system that you're using right now, I'm pretty sure it will be either of these three ranges which are defined here. The private IP address of your system, be it your mobile phone connected to the Wi-Fi, or your laptop, your server, anything that you've been using in a local area network in your own home environment or office environment, right? So the LAN that you create will always be using the private IP address space. And the moment we talk about private IP address space, we are talking about local area network. And that's what exactly it is. Virtual private cloud, the private here represents local area network. And that's exactly what it's going to provide, the capacity for you to create a local area network for your own purposes in the cloud, hence virtual private cloud. Let's have a look at it. I'm logged into my management console, and here you can see when I go to VPC, those who are wondering where did I, you can click on services, see the portfolio. Networking and content delivery. And in networking and content delivery, you'll find VPC. If not, you can just search for VPC in the search bar. Those of you who want to keep it on the ribbon here, you can just select this and put up a star. So whatever you try to, it's kind of creating a shortcut so that I don't have to search for those frequently used services. I can simply just click from here and can get started and can work on this. If I click on your VPC, you'll find that for me, there is already a VPC that exists. Now this is a default VPC. As you can see, default VPC here, it says yes. Now this default VPC is already created and kept in all the regions of AWS, right? The reason for why it is created and kept is those who don't want to get into the details of creating a network and creating subnets and route tables and other things. You just want to deploy your application and get started with it. You can simply go ahead and use this. But a recommendation from AWS is to basically create your own VPC with your own logical structure so that it becomes easier for you to manage it. It's not that you can't use default VPC. You definitely can. But for our demo purposes, we are going to create our own VPC. Now, Mahinder, you just spoke about a region, right? This is where you can choose your region from. Right now, I'm working in a region, Singapore. I've already explained this in previous Open Masterclass, but I suppose it's important that we talk about this over here, the global infrastructure part. Global infrastructure in AWS. There are multiple data centers across the world in AWS, and for redundancy purposes, so the DC that I'm writing here in circles, these are data centers. Now these are real physical data centers. AWS does not disclose the fine location of these data centers, but they definitely exist. And why is it that you have two or more than two data centers? This is to eliminate a single point of failure. Right? If one data center fails, you have the other one that can take over and continue functioning. Now, AWS says that we do not provide direct visibility or control of these data centers to you. We provide it via a logical component called availability zone. So all these real physical data centers, they are logically concatenated as an availability zone. What are the chances of an availability zone failure? Availability zone only goes down if all the data centers are down simultaneously, right? But what if in case it happens? Mahendra, do you have redundancy for availability zone? Yes, of course we do. So we don't have just one availability zone, we have two or more than two AZs such that if one availability zone fails, the second one takes over and continues functioning. If I'm trying to deploy my application, I'll try to deploy it multi-AZ. That means from not just in availability zone A, I want to deploy that in availability zone B and C maybe. And why would you do that? So that if availability zone A goes down, my application or my data is still accessible from availability zone B. I'm trying to add redundancy factor here. All of these availability zones, they make up, so if you have to call them all simultaneously or together, we call it a region. So all three availability zones, they are part of a region. Now let me show you. This is from where I can choose which region. Now if you get to the region, you'll also be able to see, that's the region selected, and here you can see under zones, I've got the region Singapore that's represented as AP-Southeast-1 in AWS. So instead of calling it Singapore, here whenever you're trying to technically define that, we type down AP, that is Asia Pacific-Southeast-1. Now in this Asia Pacific-Southeast-1, you can find we have availability zone A, B, and C. Right? These are the zones that we are using. And that's exactly what I'm trying to represent using this. So we have a region here. Let me write Singapore or AP Southeast-1, and A, B, and C are going to be the availability zones. Any resource that you will create inside AWS will either be a regional component or it's going to be a zonal resource. So the VPC that we are talking about happens to be a regional component. It works at regional level, whereas the subnets that we are going to create, the subnets are going to be zonal resources. This is a very important point I wanted you to take a note of before we can proceed on and see about VPC, that a VPC is a regional component. It is created at regional level. You can select a region and see how many VPCs it has. And then we have subnets, which are zonal components. Remember, a subnet can be a part of a single availability zone. It cannot span across multiple zones. Right? but a single AZ can have multiple subnets. So we can have subnet 1, subnet 2, subnet 3 in availability zone B. But we can't have subnet 1 spanning from AZ B to C. That's not possible. With that, let's go on and see this practically. So as you can see, I'm at VPC dashboard. If I click on your VPC in Singapore, it shows that I've got one VPC, and that too, it's a default VPC. As I told you, every region by default is going to have one default VPC that will be pre-created for you and kept. So let's check another region in Korea. There it is. The address, it's a private IP address. The address remains the same and it's default VPC, yes. North Virginia. For demo, I had created two VPCs. So yeah, there you go. I have got a default VPC. That's default VPC. And this is an additional VPC that I've created, and it's very clear. It shows that it's not a default VPC, right? In a region, you can create a maximum of 5 VPCs. But if you want to create more, you need to have a request put in, and AWS can basically do that for you, but you'll have to put in a limit increase request for the same. Let's go back to Singapore. I've selected this region for my demo, and I want to keep the slate clean here. So deliberately, I want to delete a network. This entire default network, I just wanted to delete that. Let's select it and say delete VPC. I acknowledge. There are no VPCs found in this region. Now, consequences of not having any kind of VPC, if I go ahead and try to create a virtual machine in Singapore, I will not be able to. That's exactly what happens in a data center. In a data center, the network is laid down first. And once you have all your networks in place, you have your servers that can be connected to the network and they can talk to each other. So if I go ahead and try to place my virtual machine, now definitely these virtual machines are going to need network. And here you can see we have detected that your account has no VPC in this region. This will lead to an undesirable experience and you will not be able to launch instances. For improved experience, you can create a new VPC. And that's exactly what we are going to do before we can create a virtual machine. I'm going to use the same example we had taken on the blackboard, that is 192.168.0.0. So let me create VPC. You can do multiple things. Now here I can actually make it, this may seem a little complicated for people, those who have just started with VPC. But those who are experienced, they do understand that from VPC we create subnets. Subnets are associated with route tables, and route tables are further going to have network connection information to route packets to the other networks. But I'm not going to complicate it. I'm going to start with a very basic one. So going to keep this as an option VPC only. Now here, I need to define the name of my VPC. Let's give it a name. Lab VPC. Now this is where it is asking me for the CIDR range for my VPC. The CIDR range, as we had decided, is going to be 192.168.0.0/24. I'm sorry, it was /16 that we had selected. I don't want to use IPv6. Maybe IPv6 is a topic that we can keep for other class. And we are not going to change tenancy unless and until you want dedicated instances. That's again associated with EC2. The other masterclass, next masterclass that I may have will be on EC2, and we are going to talk extensively about what is the difference between default and dedicated. Right now for this demo, I'm going to keep it simple, and let's keep everything else as it is. That's the name of my VPC, and that's the range of my VPC. Now with this range, you can understand that it is going to have a single network, and this single network can have 65,000 computers that can be connected into a single network of /16. Also, if you can read here, it says CIDR block size must be between 16 and 28. /16 and /16 is as huge of a network as you can have, and /28 is as small of a network as you can have in AWS. But Mahinder, /16 happens to be a smaller number than /28. Guys, I'm talking about with respect to how many systems can you connect into a single network. So /16 will permit you to connect 65,000 systems, whereas /28 will not be able to let you connect as many. So that's going to be a smaller network, but multiple subnets is possible, multiple networks. By default of networking rule, physical network as well, when we talk about one sub network of the same network, one sub network cannot talk to the other network. That's exactly how you're going to create a separate broadcast domain. So let's go ahead and create a VPC, and voila, with a single click I was able to create a VPC. And if I scroll here and show you, this is not the default VPC that we have. It's not a default VPC. Now, are we going to use this huge network? No, sir, we are not going to. We are going to create sub networks, and logically placed just after you create VPC, as you can see, it says you can create sub networks. No subnet found because we haven't created any. So what I want to do is I want to borrow 8 bits, all 8 bits from this network 192.168.0.0. So if I do that, what's going to happen is 192.168.0.0. What I want to do is, this is how the subnet mask looks like if I'm keeping it as /16. What I want to do is I want to borrow this entire portion, 8 bits, as network. Borrowing all 8 bits, what I'm trying to do is I'm trying to make it as 255.255.255.0. and if you do this, the CIDR range is going to be /24, and your network is going to remain as /16, but the subnets I'm going to create is going to be of /24, because I want more than 200 networks for my systems design. The way how my microservices applications are going to run, they will need more than 200 networks, but we don't need more than 200 IP addresses in each network. So that fulfills the requirement that I have by keeping it as /24. With this /24, I can create 255 networks, and in each network I can have 255, because this is 2:8, 255 systems that can be connected in each network. So let's go ahead and create a subnet. Create subnet. You need to select the VPC. And in this VPC, what is the name of the subnet that you want to give? Let's call it subnet 1. Naming convention, I want to use it a very simple one. You can be as descriptive as you want to, and that's exactly what it is that is recommended. Next is, what availability zone do you want to make this a part of? I want to make this a part of availability zone A. If you recollect, a subnet can be a part of only and only one availability zone. So I'm going to select that. And here it's asking me that for this VPC CIDR block, what is the subnet CIDR block going to be? So I'm going to keep it as 192.168.1.0/24. Now /24 is I'm carving out a subnetwork out of 0.0 by taking this entire portion as network. And I've created the first network here, 1.0. Now all the systems that I'm going to place in subnet 1 are going to have the IP address that starts with 192.168.1 dot whatever is the host portion, the IP address of the host, the machine is going to be. We'll see this practically. Again, if I'm trying to keep this, I wanted to focus on the part where it says how many available IPs, 256 in this. So let's create this subnet. Let me create other subnets. Let's create 2 or 3 more subnets so that we can use for demo purposes. So subnet 1, let me create one more. In this lab VPC, subnet 2, let's make it availability zone B, part of availability zone B. The subnet CIDR block, second network, so 2.0/24. So we have subnet 1, subnet 2. This is going to be the final one. Subnet 3. Make it part of C. Now do remember, whenever you will create a machine or any kind of resource in subnet 3, you don't have to define that it's going to be part of availability zone C. It's automatically going to become part of this. So if I'm creating a virtual machine and trying to keep it in subnet 3, it will always be part of availability zone C. 192.168.3rd network.0/24. Now, if I keep doing this 3, 4, 5, 10, 100, 500, 100, 200, 255 is going to be the last network that I'll be able to create in this. So that way, as you can imagine, I have from 1 to 255 different networks, and each network can accommodate as many virtual machines or as many IPs as mentioned here. Let's go ahead and create this subnet as well, subnet 3. So I've got all 3 subnets. Now I can go ahead and create virtual machines in each of these subnets. Instance, those who are not aware, EC2, Elastic Compute Cloud, happens to be the name of the service that lets you create virtual machines, and virtual machines here we call it as instances. I'm going to launch instance. As you can see, since there was just one network, it has automatically selected that network and randomly selected subnet 3. If you want to make a change, I can click on edit be a part of lab VPC, but I want to make it in subnet 1. So as you select subnet 1, it has automatically selected the availability zone for the virtual machine is going to be AP Southeast 1A with a CIDR range of 192.168.1.0. So the IP address that this virtual machine is going to get is going to be 192.168.1 dot. Now there is a DHCP that works by default for the network that you have created here. So IP address is provided via that DHCP. Here you can see we have something called as DHCP option set. So as soon as I've created a VPC, there are two important things which are created. One is the router, the main route table as you can see, and second is DHCP. These are created by default as part of your network. So this DHCP server that we have, the DHCP option set, is going to be responsible for allotting a particular IP address for this virtual machine that I'm going to create. Let's go ahead and launch. There it is. That's a virtual machine. And as you can see, the address, private IP address that was allotted to this virtual machine comes from the same range of subnet 1 as 192.168.1 dot, and this was allotted an IP address of 1.121 via the DHCP. So Mahendra, is it necessary that it's always DHCP that provides this address? Guys, you can definitely change this. It's not necessary that it's only DHCP that provides the addresses. You can have your own manual address provided. It's in the same range, 192.168.1 dot. So if I wanted to give this virtual machine an address of 1.10, I could have done that by selecting that I want to give manual address to the machine. Let's go back. So those are subnets created. But all these subnets that you're looking at right now, they are all private subnets. While creating a subnet, you might have seen that I never had any kind of an option where I can select whether it is going to be a public or private. This is more conceptual than technical, right? I don't have any kind of settings where I define that it's going to be a public subnet or private subnet. So let's try to see and understand what's the difference between a public subnet and private subnet. And this is what I'm discussing here in setting up VPC component. We've already discussed networking. The role of VPC is to provide a networking facility for all virtual machines and resources that you may create. So topic number 2, setting up VPC components. You've seen how to set up subnets. And now we are moving on and talking about public and private subnet, where I'm going to introduce you to the concept of route table. So let's say this is my VPC. And this VPC has got a subnet subnet 1. Same way we have subnet 2 and we have subnet 3. Right now, the VPC has got something called as a default or main route table. Let's have a look at the main route table. So if I click on VPC, that's the main route table. And that was created by default. When I created the VPC, Virtual Private Cloud, the network that we have created, Lab VPC, has got an automatic main route table. And you can find that route table here. That's the main route table for Lab VPC. Now in this route table, I wanted you to focus on the default route that it mentions. And this is applicable for the VPC and all the subnets which are part of. As you can see, that when I show you subnet association. So let me also draw this for you. That's the main route table that we have. Main route table. Pardon my handwriting here. This main route table has got a route entry. For those who are wondering what exactly route table is, guys, in networking, if you want two different networks to talk to each other, we place a component called a router. Now, since this is software defined, since this is more of resources being controlled by AWS, AWS does not provide you any router interface, be it, I'm not sure, maybe Cisco router or 3Com or Juniper, right? But what they give you is, what does a router have? Router has route table entries. So they have given you a facility of route table through which you can manipulate the route table entries, and that's what gives you a power of directing the traffic from one thing to another, right? So this subnet association, by way of not explicit association, whatever subnets you will create, since this happens to be the main route table, automatically that subnet is going to be counted as part of this main route table. So let me also give it a name, and you can main route table. So this way I know that this is a main route table, right? Again, going back to the drawing, and all these subnets, since this main route table is part of this VPC, all the subnets which are created are associated with this main route table. Hence, any kind of routing that happens, a virtual machine from this subnet wants to transfer the data to another virtual machine in subnet 2, because the route table entry has a route that says that this is permitted, so subnet 1 can talk to subnet 2, right? That's exactly what is being shown here. Since all the subnets are part of this main route table, there happens to be a default entry, and this default entry turns out to be that all the machines who want to reach out to a destination, which is 192.168 dot whatever, right? They all can talk to each other. So target local, they all can talk to each other. So this default route table entry says that all the subnets which are part of this route table will be talking to each other. If this was a physical network that I would have created, in physical network, creating multiple subnets will make sure that none of the subnets talk to each other. It is only by connecting them to the router. So you have multiple LANs, the switches in the LANs, they connect to a router. And in the router, I will have to make a setting where I have to say that LAN 1 can talk to LAN 2 or LAN 3. Only then this is going to be possible. Now here it happens by default because the main route table has the entry, and this entry cannot be deleted. Now, if I click on edit route, there is no way how I can delete this entry. Right? I can't. So by default, all subnets can talk to each other. That means all the virtual machines of each of these subnets are permitted to talk to each other. Hence, any virtual machine that you'll create right now in any of these subnets, and if you try to ping, there are other components which will come into picture later, but if I neglect them, take them out of picture like NACL and security group, all machines amongst these subnets, they can talk to each other. But this is not the only world that we have, right? We have something called as internet as well. So let me draw internet here. And people are connected to your network VPC via the internet. So let's say this is a customer that I have connected through the internet. Right? Sorry, let's make it. If I can. Yep. Right now, the route table does not have any route entry that will let this machine using internet to get in here and through this to reach out to resources inside the subnet. None of the route table entry says that. So if somebody from the internet cannot send a request to your resources inside the subnet, this subnet is termed as a private subnet. It's private, right? Because nobody is sending a request and it's not going through to your subnet. How do you make it possible? We make it possible by making a route table entry, and instead of making a route table entry, I'll create a different route table which is not going to be the main route table. So let's create a route table. I'm going to call it a public route table. And I want to associate subnet 1, an explicit association of subnet 1 to this route table. And inside the route table, I'll define an entry how to send data out to the internet and how to get the data in from the internet. For this, we'll need one more component known as internet gateway. So internet gateway is the only gateway through which it becomes possible for you to be connected to the internet. Nothing in this world can connect a VPC to an internet other than the internet gateway. And that's exactly what is part of. So route table and internet gateway. Right after the route table comes internet gateway. And that's exactly what I'm going to do. I'm going to create the internet gateway first, and then I'm going to go back to route table to show you how. So let's create internet gateway. I'm going to call it IGW. That's it. You just have to define a name for your internet gateway. And right now it says that this internet gateway is not serving any VPC. It's detached. So after creation, I'll have to attach to lab VPC. And now you can find that internet gateway is attached to lab VPC. Going back to the route table, as I said, I'm going to create a route table with a name public route table. So let's do that. Create route table. Let's call it public route table for lab VPC. So that's my public route table. And I want to make an explicit association that I want my subnet 1 to be explicitly associated with public route table. So let me click on edit. And as you can see, subnet 1 right now is associated with the main route table. I wanted to associate now, disconnect from main route table and become part of this public RT, public route table. So subnet 1 with explicit association is part of now public route table. And in this route table, if in case it's difficult, understand that a route table is a router. So right now my subnet, I've just connected my subnet, a LAN, a local area network, with a different router, a different public route table, or public router maybe. Now the reason for why I gave it a name of public route table is because I want to make it public by defining a route. As you can see, subnet I've already associated. And now I'm going to define a route. And say that apart from a question, if somebody is asking who is 192.168.x.x, it's going to route locally. If you don't know, match all. So this is a wildcard expression that says kind of match all. What this means is, if any question that you may have, I want to find out who is 35.44.55.66. This may be an IP address of one of the machines on the internet. Or let's find out the IP of Google. Google.com. Yeah, 142.50. That's the IP address of google.com right now. 142.250.77.36. Is it the same question as 192.168? No. If it is not the same question, then the route entry that says match all in a way. So that means matching all. So if you have any question related to anything other than 192.168, you go and ask how to reach out via the internet gateway. So as you can see, I'm saying that if you have any questions regarding reaching out a particular IP address, maybe that's not the private IP that we are talking about, 192.168, but anything else, if you have question and you want to know how to reach out, go and talk to internet gateway. That's exactly what I'm defining as part of this setup. Save changes. And by way of this route entry, I just made the subnet a public subnet. There is no type. It's just with the help of this route table entry that you make, you have created this subnet as a public subnet. Now, why am I saying this? Why is it a public subnet? It's a public subnet because anybody from the internet can send a request via internet gateway, and this internet gateway has an association. So the connection passes through. The route table entry permits the data to be sent into the subnet and anything that comes out of the subnet to be sent back. So that means the resources of this subnet can send the data out, that means outgoing request, and accept the incoming request. When that happens, these resources are exposed to the public domain, that is to the internet. And since you are exposing it to the public domain, the subnet is taken as a public subnet here, is known as a public subnet. Let's go back to EC2. Or before going on to that, but Mahendra, then what happens to the other tables which are not explicitly associated with this? Since they are not explicitly associated with this, by default they will be associated with main route table, and main route table does not have an entry for internet gateway, and anything that does not have an entry for internet gateway is termed as a private route table. Subnets which are part of private route table are termed as private subnet, because nobody from the internet, so private route table, nobody from the internet can send any incoming request to resources in subnet 2 and 3. Hence, they are private, they are not publicly exposed. Let's keep it that way, and let me go ahead and show you. And while I'm doing this, I'm sorry, I could have arranged VPC security group and NACL as the third point. But let me bring up we've already done this. And now what I'm going to touch upon is VPC security. How do you implement security in VPC? So next I'm going to talk about is security group and NACL. Now, since subnet 1 is part of public route table, and public route table has already got an entry for internet gateway, this is in subnet 1. This virtual machine that I have here is running in subnet 1. What I want to do is, this is the public IP. Every virtual machine that you'll create, some additional settings are needed, but of course when you're creating it, so you can have a public IP associated with your virtual machine for management purposes. So since I want to manage this virtual machine, I'm going to use this public IP, and let's try to see if I can connect to this virtual machine having address of 13.212.253.140, and it says I can't. It's not because I don't have the route path to reach this virtual machine, but because this virtual machine is protected. It's protected with the help of firewall, and those firewalls are security group, and we have another thing called NACL, Network Access Control List. Let's try and understand the significance of these two. I'm going to use Blackboard for the same again. That's the VPC in the example. Now, each of the subnet that you see in VPC is protected using a firewall, and this firewall we call it Network Access Control List. Network Access Control List is a firewall that protects the perimeter of individual subnets. What gets into the subnet and comes out of the subnet is all protected using NACL. Now this network access control list is a firewall, which is a stateless firewall. Stateless, it does not remember, it does not maintain the state. It cannot remember what was the incoming request that needs to be permitted for outgoing as well. For example, if I sent any request to a resource inside a subnet, let's say a virtual machine inside a subnet, I will need a rule for this, for incoming packet or incoming request. Now for this request, there is going to be a response, right? So for response as well, I will have to explicitly define a rule, because it cannot remember anything that it permitted here, right? Stateless, it does not maintain the state. So NACL, if you're defining a rule for incoming, that port number 80 or port number 443 or any other service that you are running on virtual machine inside the subnet, you are accepting the incoming request, you will have to explicitly define the outbound path incoming request for the response for the request that is incoming. For the response as well, you will have to define a rule, stateless. So that's NACL, Network Access Control List. For individual virtual machines which are part of the subnet, for individual virtual machines, we have what is known as security group. Security group. So there are two layers, as you can see. The first layer is incoming request. Network access control list is going to control what gets in, but as soon as the request gets in, before it can reach out to a virtual machine, the next layer of defense is security group. Now security group is a firewall. It's again a firewall that protects perimeter of individual virtual machines inside the subnet. So what can get into and out of the virtual machine before it, right? So this is going to, let me, so what gets in and what gets out. It is at the subnet level, the network access control list is going to protect, and as soon as it gets into the subnet, the packet gets into the subnet, before it can reach a virtual machine and a virtual machine replies back for that incoming request, the security group is going to play its part. Now the security group that we are talking about is a stateful firewall. What that means is you just have to define the permitted incoming request. Outgoings are all by default permitted, right? In security group, the default rule is outgoing is always permitted. Outgoing is if this virtual machine sends any request out. Incomings are always denied. Outgoing is always permitted in security group. NACL is not the same case. In network access control list, neither incoming nor outgoing, nothing is allowed. So you'll have to explicitly define the rule. Let's go back to the screen and have a look. This is where we have network access control list. Now network access control list, we have this default network access control list for the VPC. And if I show you the details, it says all traffic allow from anywhere for incoming, and for outbound as well, it says all traffic allow for destination for anywhere. Network access control list has rule numbers ranging from 0 to 65,535. the lower the number, higher the priority of the rule. Whether it is inbound or outbound, the lower the number, it is inversely proportional. Lower the number, higher the priority. Now this is only for network access control list. Now as you can see, the default NACL permits, and default is when you have created a subnet, if you have not explicitly associated the subnet with the NACL, it becomes part of the default network access control list. In default, all inbound and outbound traffic is permitted, it's allowed. And hence, we don't have to define any rule for NACL unless and until you want to make sure that there are certain kinds of traffics you do not want to permit no matter what. Right? You can define that at subnet level. So I'm not going to make any changes. We are going to keep it as it is. Let's have a look at security group. There is this default security group. Again, created by default whenever you're creating the VPC. Outbound rule says all traffic, all port range for all the destinations are allowed. Inbound rule says that only internal traffic which are part of this security group will be permitted. So what I'm going to do is I want to make sure that I have a rule defined for inbound rule, since my virtual machine that I'm using, the instance, is connected to this security group, the default security group, this instance. Hence, it's using the rule defined here. Now that says that only the internal traffic is permitted which are part of the same security group. But I want to edit inbound rules and I want to add a rule for security group, and we can keep it running here. The ping keeps running here. And I want to do that for ICMP. All ICMP traffic permitted from only my IP address, that means only from my network, from anywhere. So this represents that it can be done from anywhere. Rules with allow, now, as you can see here, it shows a warning message that this is not safe, which actually it is not. This is just for demo purposes that I'm doing that. But otherwise, what I would recommend is defining a specific IP block which is permitted to do that. In my case, I can just select my IP. My IP is only for my public IP that is being used for my machine. So as you can see, as and when I permitted the inbound rule, permitted inbound by defining that permit all ICMP, right away you can see there is a reply, ping reply that comes back for the same machine. So this is security group. Now if I want to log into this machine, let's select connect, and I want to log into this machine. Now if you ever want to log in, you want to make sure whatever protocol you're going to use for logging in, for example, SSH, you want to make sure that you have inbound request accepted defined for SSH as well. So you'll add additional rules and you may say that I want to permit SSH. As soon as you select a type of protocol, it automatically fills up the other details like port number and protocol. And then you can define whether you want to do it for anyone or a specific IP block. A specific IP block, you can select it. So significance of security group and network access control list. Again, let me repeat that. NACL is a stateless firewall that protects perimeter of individual subnets, and security group is a stateful firewall that protects the perimeter of individual virtual machines in the subnet. Moving to the next part where we talk about private connectivity, peering and VPC endpoint. Let's have a look. VPC peering, if you want to do this, or why would you want to do this? Why is it needed? Let's bring up the Blackboard again. Now you may have two VPCs. This is VPC 1 and that's VPC 2. I'm not drawing the subnet, but you understand that a virtual machine cannot exist entirely into a VPC. It needs its own subnet. Every virtual machine that you'll create will have two types of addresses defined. For LAN purposes, local area network, it's going to have a private IP address, and for management purposes, it will have a public IP. And you can practically see it. As you see, we have a public IP address courtesy of AWS. It provides a public IP for management of individual virtual machines. And we also have private IP address used within the LAN, local area network. Same is the case here with our first VPC. And it does not matter whether the VPC happens to be in the same account or different account, or same region or different region. This concept is applicable for all conditions. Private IP, and this too has public IP. It's not necessary that these two VPCs be connected. These virtual machines that I'm talking about, VM1 and VM2, VM1 and VM2 can talk to each other by connecting. This is by connecting via internet using public IPs. Can they talk to each other? Yes, of course they can, using public IP. But the only problem here, if you consider security, my data traverses the internet. I don't want my data traversing the internet. Internet is not a safe place. So when I'm designing, I want to make sure that my data remains as private as possible. So is it possible for these two virtual machines to ping each other and talk to each other? Yes, of course it's possible. Using public IPs, we can. But do we want to do that? No, I don't want to. I want to make sure that I use private IP addresses, making sure that all the data that traverses remains within the confines of AWS network. It does not go onto the public internet. I want to avoid that. So the way how you can avoid in between two VPCs, as I said, does not matter whether these two VPCs are in the same region, different region, or they are part of the same account or different account, right? What you are going to do is you are going to create what is known as a peering connection between these two VPCs. VPC peering. And when you do that, VPC peering will let the private IP address be used for communication. And when that happens, your data remains within the network of AWS, a private network. It does not traverse the internet. When that happens, I can be rest assured that my data happens to be safe and using a safe channel to basically send like to and fro. The only thing that you'll need in this is these two VPCs must not have overlapping CIDR ranges. Now, what do you mean by overlapping? If and the other VPC as well has the same CIDR range, This is termed as overlapping. If you have this scenario, if it is overlapping, VPC peering is not possible. We want to make sure that we have different networks that we are using for VPC. The CIDR ranges must differ. Right? Second thing in VPC peering is VPC peering does not support transitive peering or transitive routing. What that means is, if you have three VPCs, let's say VPC A, VPC B, and VPC C. If A has an explicit connection, this is the reason for why it is known as peering connection. It's a peer connection, A to B. And if B has connection with C, most of the time people take it as, okay, you can hop here and then from here you can get into VPC. Sorry, that's not possible. That's what is known as, you're using VPC B as transit. Transitive peering, transitive routing not supported in VPC. If you ever want A to talk to C, you need to have an explicit connection, explicit peering between A and C. So these are the two important points for VPC peering that I wanted you to remember. Now back to our screen and let's see this practically. So what I'm going to do is I'm going to go to another region where I have one more VPC. As I said, this can be in the same region, same account, different account. I don't have another account, but I'll use the same account and let me show you practically how it is done. Delete this so that there is no okay. Show me only for default VPC. Now, as you can see, this is the CIDR block of default VPC in North Virginia. I want to peer it with this VPC in Singapore. How are you going to achieve that? For this, we go to peering connection in VPC. We click on create peering connection. I give it a name peer 1. So I want to connect my lab VPC from Singapore. That's the CIDR range. Now the next VPC where you want to connect it to, you want a peering connection to, is it in the same account or different account, or is it in the same region or different region? As I said, does not matter whether you're in the same account or different, or same region or different, you can choose. Now what I'm going to do, since it is in my own account, but it's in another region, so I'm going to select another region, and the next region is North Virginia, and I need VPC ID of a VPC in North Virginia. This is the VPC ID. You need this information from your subordinate. Maybe if it is in a different account, you are going to ask that account owner or the admin, what is the VPC ID? And we are going to click on create peering connection. This is sending a request. Right? It's sending a request. Now this is where it appears for North Virginia. So from Singapore, we made a request to the VPC in North Virginia. Status shows failed. Let me check this. It's very clear. Failed due to incorrect VPC ID, account ID, or overlapping CIDR range. Let's delete this. Only if it permits me to delete the peering connection. We try and create another one. Demo peering 1. Requester lab VPC. My account, another region. One 3 CD6. So there you go. Now the status shows initiating request to. And if I go back, as I said over here, refresh. If you can ignore the first one which failed, here it says pending acceptance. Right? The requester has made a request. Unless and until I accept, the connection won't be established. So accept request. Perfect. Provisioning. And it's active. This is North Virginia. If I go back to Singapore, let's refresh. Demo peering 1 is active. Now, an important part. If I want the virtual machine in North Virginia to ping a virtual machine in Singapore, let me start this virtual machine. I want you to also focus on where exactly am I working. I'm working in North Virginia here. This, I just wanted to start so that we can check. I wanted to let you know that this information or this peering connection has already been established. But as I said, for this machine to know, it needs to know the way how to send that packet over using this peering connection, over to the other network. Now this information of directing the traffic can only be done by route table. It's only the route table that has information how to direct traffic from one network to another network, right? So route table entries are important even if in case peering connection is established. Unless and until you make a route table entry, the ping or the connection is not possible. Let me check. Since this machine is running, let me connect to this machine. And I'm going to call this machine North Virginia virtual machine. So this way it becomes easier for us to track and understand. this machine in North Virginia, the private IP address is 172.31.38.101. A virtual machine in Singapore, 192.168.1.121. Let's do this. But before I can do that, let me also remind you that I'm having a security group, and inside security group, do I have inbound rule to accept incoming requests from everywhere? No. I'm sorry. So we are going to edit inbound rules, and instead of saying that only my IP address, I want to permit it from anywhere, ICMP. This is an important part. People set up of everything and then they are like, we are trying to ping and it's not working. It's not working because the firewall rules have not been checked. So I checked firewall rule, inbound request for ICMP, I've accepted from everywhere. This is in Singapore. Going to my machine here in North Virginia, and I'm trying to ping 192.168.1. IP of this instance 1.121. It has no idea how to reach 192.168.121, even if the peering connection is established. Now the reason for why it is not aware, as I said, is a route table. So we are going to, in the route table, we will define to reach out to VPC2, use peering connection. And same thing will have to be done into the route table. Now, if you can match this color coding that I'm using here, I will have to define in this route table that to reach out to VPC1, you need to go using peering connection. This is the entry we will have to make for this peering connection to work. And that's exactly what I'm going to do next. This is part of default VPC, BBE8 subnet. Let's check. That's the subnet BBE8. It's in US East 1A. Route table. That's the main route table. Subnet association. BBE8 without explicit association. As you can see, this is BBE8. I want to make a route table entry in this. And I want to say that if you want to reach out to 192.168.0.0/16, if you want to reach out to this, go via a peering connection. This save changes, creating a route table entry for peering connection. It's done from this side. We'll have to do the same from Singapore as well. So let's go to route table. And since it is for this first, I'm going to make an entry here for public route table for my subnet 1, because subnet 1 was explicitly associated. Edit route table, add a route. And this side, I'm going to enter the default VPC CIDR block. That means if you want to reach out if you ever want to reach out to 172.31.0.0/16, go via peering connection, demo peering 1. Now, here it's not pinging, but the moment we complete this route table detail, as you can see right away, it starts pinging, and same thing is going to happen for if we go to the other machine and try to ping. So it's not just creating the peering connection, but it's also needed that you define in the route table how to use that peering connection as the hop to go to the other network. So that was about VPC peering. Now let's have a look at VPC endpoint, which is again created for the purposes where the use case may be that I wanted to have a private connectivity for reaching out to AWS services as well. Maybe it's not just from one VPC to another. Maybe I am working with some AWS services that I want to make sure that I can reach out to those services privately. Now, all the AWS services which are exposed in the world, they are all public services. That means you can reach out to these AWS services from anywhere in the world. These are all public facing services. Let's say if you want to reach out to this S3 service from anywhere, what's the endpoint for S3 is S3 AmazonaWS.com. From anywhere in the world, if I try to ping in, I can reach out to this S3 service, as you can see. Right? Now let's bring up a scenario to understand why VPC endpoint can be a useful thing. Now this is AWS. Within AWS, you create a VPC. That's my VPC. But VPC is not the only service. AWS also has a service called S3. It is within the confines of AWS. Right? My VPC definitely has a subnet. Now imagine if this subnet happens to be a private subnet. Give me a minute here, guys. Yeah, I'm sorry. Let's move on here. Yeah, imagine if this subnet happens to be a private subnet in any case, or maybe the virtual machine that I'm running in this subnet does not have a way to reach out to the internet. Any application that is running in here will have to send the data to the internet, and from here it will reach out to S3. Even though the S3 service happens to be within the confines of AWS, the virtual machine will have to use the public IP of S3. Anyway, whenever you use public IP, you are definitely routing the traffic through the internet, and that's exactly what is being displayed here, being shown here. Now this needs that your virtual machine running in the subnet needs to have a public IP of its own, because it cannot use private IP for public communication or sending the data to the internet. So first need a requirement, the virtual machine needs to have a public IP. And if in case your subnet happens to be private, you will not be able to, right? You can't do that. So two things. First is I want to make sure that the data that traverses must not be traversing the internet. I want to reach out to the S3 service using AWS's own private network, right? So that way, even if my virtual machine is not public, it's a private subnet that we are using, it's a private virtual machine, it can still send read and write data from this service. The concept that we are talking about is only applicable for services. It's applicable for services. We are not talking about VPC peering. We are talking about a facility that is provided in VPC called VPC endpoint. So what we do is, rather than using this, we create a VPC endpoint and the machine uses a private IP. In fact, the VPC endpoint is also going to have a private interface. And this endpoint is by default associated with a particular service that we define. Right? So virtual machine can reach out to this S3 service without traversing the data through the internet. It's sending it to the VPC endpoint, and VPC endpoint uses its own AWS PrivateLink to basically have the connection to S3 or any other service. This is not just for S3 but any other service. Let's have a look at it practically again. Let me go to the instance. So I'm going to connect to the instance using SSH. North Virginia virtual machine. This is easier to remember. So that's North Virginia virtual machine. That is my virtual machine. And this is my own laptop that I have here. Logged in. Let's see. From this machine, if I say ns lookup for a particular service, let's not use S3 as the example here. Let's say it is any other service that is being referred to in the application running on this virtual machine. Now that application can be an application written by you, or it can be an application that is written by it can be an application that you're using, say for example AWS command line. So US-East-1, that's North Virginia, Amazon AWS.com. If I try to do ns lookup, you can see the IP address that it shows for this service using the endpoint is a public IP address, right? This is what I don't want. I don't want to send data, anything that shows as a public IP. From this machine, I want to send it to a private IP address, making sure that I can still reach out to this service, but using my own private network without traversing the data to the internet. For this, we go to VPC and we are looking at PrivateLink endpoint. I can say create endpoint. So what we are trying to achieve, as I said, from my virtual machine that I'm running here, I want to reach out to any service. SQS can be one of the services. I want to reach out to this service, and I want to reach out not using a public IP, but a private IP address. So this is where I'm going to create the endpoint. You can find PrivateLink. AWS PrivateLink is what is the kind of technology that is used to enable this feature. Let me call it demo endpoint. And this is for which service? This is for a service called SQS. The VPC for default VPC. And you want to do that for, I want to do that only for subnet A. Now this is going to create an interface that will connect to SQS. And I can use default security group. Let's create an endpoint. It's in pending state. As and when it gets created, I'll show you the details of it. At the same time, if we go ahead and have a look at the network interface, which you can find in EC2 network interfaces, I want you to see this. VPC endpoint interface has created an interface for VPCE 1E08. 1E08, that is the VPC endpoint. It's available now. And I want you to focus on the IP address for this interface that it has created, 172.31.35.52. If I go back now and I try to do NS lookup, I haven't changed anything on this machine. But you can see now it's using a private IP address, not a public one, a private IP address for SQS service. Right? Now, what benefit does this have? As far as benefit, there is security. As I said, the data is not traversing the internet. The data reaches out to SQS service from any application running on this virtual machine in North Virginia using a private link, using a private IP address. So the data remains within the confines of AWS network. So that's about VPC peering and VPC endpoint to enable private connectivity. Now let's have a look at hybrid networking, where I'll talk about VPN, transit gateway, and direct connect. After that, we'll have a session open for some time to take some questions and answers from your side. So let's look at hybrid networking. To understand the term hybrid is basically a cloud computing deployment model. Hybrid is where you have some part of your application running from your own data center and some part of it may be running from AWS. For example, the database of your application resides on-prem but your web and application layer in AWS. So any incoming request to web is going to target application layer, and application layer will need a way to talk to the database. But the database is not in AWS, it is on-prem. I want to make sure that these two sites, on-prem location, that is data center, and AWS is connected together. Only if they are connected will there be a possibility for me to send and receive data. This is what is needed right now. So hybrid cloud deployment model defines that some part of your workload is running in the cloud and some part of it is running on-prem or in your own data center, and that's the reason why we call it hybrid. It's neither completely cloud-based or not completely on-prem based, that is in my own data center. It's kind of hybrid, right? Now there are multiple options. The first feasible option that I'm going to choose, maybe if you're working as a solution architect, considering the amount of bandwidth that is needed and the kind of work that is to be done, I can choose VPN connection for this virtual private network. It is going to be site to site VPN connection. So what happens is, in AWS we have what is known as a virtual private gateway. A virtual private gateway in AWS that connects to your VPC, and from the on-prem location there can be a router with a capability of VPN. By configuring this, and you have that facility in VPC, here it is, virtual private network. To be able to do this, I will have to create a virtual private gateway, attach it to the VPC. So virtual private gateway being created, attach it to the VPC that you have created. And then once it is attached, you can go ahead and define customer gateway. The customer gateway that I am talking about happens to be the router on the customer side, that is on-prem, the public IP of that router. Once you've defined that, third thing that you do is go ahead and create a VPN connection between the virtual private gateway and the customer ID. There are additional steps for configuration, which is out of scope for this particular class now. But once you establish, you will have VPN connectivity between on-prem, and using this connection, this becomes possible. Now VPN, those who are aware about it, I'm pretty sure you might be using some or the other kind of VPN to connect to your office. Virtual private network creates a tunnel, and that tunnel provides protection from any kind of malicious attack or any kind of session hijacking. So those things can be prevented with the help of this VPN connection that presents you a kind of, in a way, encapsulated private channel that lets you transfer the data to and fro using a secure channel. An important point to note is this VPN cannot provide more than 1.5 Gbps of bandwidth. This is limited to just 1.5, 1.25 if I'm not wrong. That's the only amount of bandwidth that you're going to get. So if the data transfer needs that you have happens to be huge as in you are looking at 5 Gbps or 10 Gbps kind of link to transfer the data, then VPN goes out of question, right? It cannot handle as much bandwidth. That is where we bring in direct connect. We have DX. where VPN happens to be an instantaneous connection. You can establish and start using right away within say 15 minutes or 20 minutes of configuration. Your VPN is going to be up and running and you can use it. But in case of direct connect, it takes time. It's not an instantaneous connection. If you click on create connection, right, direct connect, depending on whether you are located in the same place as AWS data centers are, once you submit the request from here, AWS is going to process that. They will see if they are located in the same place as you are, and then they are going to provide and this is a hypothetical example that I'm using, but an easier way to understand. Now we are not talking about VPN, we are talking about DX. Direct connect. The connection that you see here being established, this, as if you imagine, this is basically a fiber optic cable, a huge fiber optic cable. One end of that fiber optic cable is connected to your own on-prem location here, and the same fiber optic cable stretches out and connects to AWS. Now, if you can imagine this kind of connection, it's kind of an extended local area network that is provided to you. This is giving you a dedicated private connection from your data center to AWS. This can offer you a bandwidth of 10 Gbps, and if you use link aggregation, you can aggregate multiple connection. You can find higher bandwidth as well, like 100 Gbps if you need. You can definitely create links of like 50, 60, 100 Gbps. And let me repeat this, it's private, dedicated for your usage only. It is not a shared connection. Depending on whether you're located in the same place, it may be handled by AWS. But if you are located in a place where AWS does not have a presence, right? Located in the same place as AWS data center, we call it co-located. So if you're not co-located with AWS, AWS provides partner. You can select partners. Maybe I want to do that for Mumbai. So we have CFI, Equinix. These are all partners who can provide the direct connections. Here you can see. So in Mumbai, I have Bharti Airtel, NetMagic, Reliance, Jio, CFI, Tata Communications, Vodafone. These are the partners who can provide that connection if you are not co-located. Now, going back to the Blackboard, this portion that you're looking at is very important. This is what is used for VPN connection as well as direct connect. This is a virtual private gateway, a resource that you'll have to create and attach to the VPC where you want all the data packets to be flowing. Now, virtual private gateway is an old, I can say an old component that lacks a lot of features which may be needed for today's world. For example, it lacks ECMP, equal cost multipath routing. It also, as far as the management of it is concerned, it becomes a little complicated. I'll show you how. Now, shortcomings of virtual private gateway. Let's say I've got multiple VPCs in my account. VPC 1, VPC 2, These are 4 different VPCs that I have, and I have a branch office here. My branch office is using multiple types of connections. It's using VPN as well as direct connect, right? Now, whether you want a VPN or you want a direct connect connection, you will need a virtual private gateway to be attached to every VPC. Then you have your own router, the customer gateway. And from this router, you will have to establish a connection, as I said, multiple connections. This is what the structure looks like with virtual private gateway. It will not be wrong if I say that there happens to be an easier and better way of doing this by replacing your virtual private gateway with what is known as transit gateway. And that's exactly what we are doing next. Transit gateway. This is more about management and routing. So a virtual private gateway connection looks like this. Now, what if in case I replace that and I say that you don't need multiple virtual private gateways and you don't have to manage connections like this. Rather, what I provide is I provide a transit gateway. This is transit gateway. Now this transit gateway uses what is known as a hub and spoke topology. Hub and spoke topology. That means all the VPCs can connect to this transit gateway, and one transit gateway can fulfill the requirement for almost 5,000 networks. So that means 5,000 VPCs can be served. Your customer gateway will maintain only one connection with the transit gateway. So it is connected to the transit gateway, and transit gateway in its turn is connected to multiple VPCs, right? Transit gateway internally maintains what is known as transit gateway route table. And with route table entries that you can maintain, you can permit who can talk to whom. For example, I can create a route table entry and say that customer gateway can talk to VPC1. Now this kind of route table entry that comes in, route table will start permitting any kind of incoming or outgoing request to this. Now transit gateway is not just useful for VPN connection. Here you can have, this can be a VPN connection. You can also use it for direct connect. So let's say I may have another branch office or the same branch office for this direct connect connection, DX. Same transit gateway can be used, and with the help of transit gateway route table, you can manipulate the route and you can permit the data flows from your branch office into multiple VPCs. So this portion remains constant. You don't have to maintain multiple connections. From your branch office, you're going to manage only 2. Rest everything else will be done inside transit gateway to allow, let's say VPC2 can talk to and use direct connect. VPC3, right, can talk to each other. This hub and spoke topology permits me to make management a little more easier. Again, you can find that in VPC. Right? Let me create transit gateway. I want to use all the features. Let's call it TGW, transit gateway. Now, once we have transit gateway ready, we are going to create, this is going to be acting as a hub. We are going to create attachments, which are going to be spoke. It's available. Let's go ahead and create transit gateway attachment. Create transit gateway attachment. Let's call it VPC1 attachment from transit gateway to VPC. I want to attach default VPC, all the subnets. That's an attachment. So VPC1 attachment created. I can create another one. Let's say VPC2 attachment for transit gateway for lab VPC. Done. Same way I could have done for other VPCs. Now, when I'm going to create a site-to-site VPN, rather than using a virtual private gateway, or also for DX, if I'm trying to create it, rather than connecting to a virtual private gateway, I'm going to refer to this transit gateway. And as and when I'll need to define that VPC1 can talk to VPN1 or VPC2 can talk to DX1, I can define all of that in this transit gateway route table. I need to define the association, right? Once the transit gateway attachment becomes ready. So with the help of this route table, you'll be able to manipulate and control who can talk to whom, which are connected to the transit gateway. So guys, that's it about the agenda. That's it for this AWS VPC. Now I'm going to keep the session open and we are ready to take some question answers here. So guys, anything that you may want to ask, you can put it in chat. Hey, thanks Manish. Thank you so much. So guys, waiting for questions if you have anything. If not, I guess it's time we can close this. And if you have any queries, you know how to reach out to me. You can send me queries. And till then, happy time. Have a good day, guys. I'll see you for the next open masterclass. Bye bye.